Hello everyone, welcome to day 8 on my journey of becoming a software developer. In today's problem we're going to be solving number line jumps. For this problem I felt at some point that I needed to do like a little bit of a physics refresher, if you will, but the problem ended up being a little easier than it looked. It was just a matter of approach, finding the right input. So just follow me on the video. If you like the video, if there's anything of value in it, please like and subscribe. I'll be hearing from you in the comments. Let's go ahead and do it. Alright, welcome to day 8. We're going to continue our series, solving problems. Today we have number line jumps. It's the following problem after apple and oranges. If you haven't checked that one, go ahead and check it out. The purpose of these videos, if you're new in the channel, is just to deep learn topics in, my case, software development, coding, preparing for coding interviews in a few months. I've given myself 4 to 5 months, somewhere around 100 days to be ready for an interview, and this is the process, and I decided to document it and post it somewhere. For now I think it's YouTube, but if you're here, hope you stick with me, and let's go ahead and jump to the next problem. Alright, the problem says you are choreographing a circus show with various animals. For one act, you're given 2 kangaroos on a number line ready to jump in the positive direction towards positive infinity. Okay, the first kangaroo starts at location x1 and moves at a rate of b1 meters per jump. Okay, the second kangaroo starts at position or location x2 and moves at a rate of b2 meters per jump. Okay, you have to figure out a way to get both kangaroos at the same location at the same time as part of the show. If it's possible, return yes, otherwise no. Interesting. Example, we have, they said x1 location of the first kangaroo, velocity or jump rate of the first kangaroo, location of the first kangaroo, and velocity of the second kangaroo. Ooh. What was that? After one jump, they're both at x equals 3. They add all the velocity plus location plus 1. Okay, 2 plus 1 equals 3, and the sum of that equals 3. So the answer is yes. Okay, I'm sure I totally understand why. Okay. Basically, one kangaroo have a head start, but the other one has better speed. So the ground that one covers equals the speed of the ground that a kangaroo covers with distance. The other one has to catch up with speed, basically. We're good on that sense. Description, complete the function below. Kangaroo has the following parameters: integer x and integer v. 1, that's the first kangaroo parameter, so distance and position, distance of the jump and positions. And then the second kangaroo, return. Okay, we know we're going to be returning something instead of printing and so forth, right? Just a string. Okay, and yes and no. Interesting. A single line. Okay, this is just the input. For, I believe, for HackerOn, they use standard input. That's what we always see, this kind of stuff. And lately, I don't know what's been happening with my, I don't know if it's something I have installed here or whatever, but it's been hiding my inputs here somehow. Anyways, we have 0, 3, 4, 2. So that's the first kangaroo. Starting point is 0. His velocity is 3. The second kangaroo started ahead of the first kangaroo, but his speed is slower. Right. And that's kind of like what they're mentioning here. Well, in this example, basically, like, we see that one kangaroo is going to be faster and the other one is going to be, one's going to be faster and the other one's going to be ahead in position. let's go to the fun part, which is the graphics here. I always love when they do something visual. That's, for me, that's the way to learn. But anyways, we have position 0. So we have the 2 kangaroos. One started at position 0. I believe that's the sample input. That's here. 0, velocity 3, or distance of the jump, whatever. It's the same thing. It looks like a vector, where distance definitely matters. So yeah, these sounds like kinetics or something. I don't know. Anyways, let's go ahead and check this 3. This one's at position 4. So it has a slower jump, but his position is 4 steps ahead. His starting position is 4 steps ahead of or 4 meters ahead of the first kangaroo. But the first kangaroo has a faster jump, or a larger jump, covering more ground. So eventually we see that after jump 4, they both meet at the same position. It's clear the kangaroos meet at the same location, number 12 on the number line, after the same number of jumps, 4, and we print yes. Sample input 0253, sample output no. Explanation: second kangaroo has a starting location that is ahead, further to the right. Part of my English today, guys. Sometimes I run low on balance. I promise you it's better. Of the first kangaroo's starting location, which means the location of the second kangaroo is greater than the location of the first kangaroo, because the second kangaroo moves at a faster rate and is already ahead of the first kangaroo. Obviously, they will never meet, because the first kangaroo started at 0, the second one at 5, 2 and 3. Yeah, they will never catch up, because this one is just a winner kangaroo. Anyways, I think this is a little bit of math here. It's not my main topic. It's not the thing I love the most. But I think it should be not too complicated, but I know I'm definitely gonna have to cover. So since we're printing yes and no, I can already tell that we're gonna be covering conditions and especially Boolean values, or not necessarily Boolean values, but that's basically what we have to produce. It's good that we don't have to, for instance, would be different if we have to say, if we have to print the position where they meet, right? This number right here. It would be a different type of function. But for now, we just have to determine if in some point in infinity future they'll meet, right? So I'm gonna go ahead and get my whiteboard on this side. I got the other screen here, you guys can't see. Just can't record both for some reason, but that makes sense too. So I'm not gonna jump ahead because there's probably some things I gotta get, but basically let's get these on. Basically the position, what's happening? Oh, here we go. Are we working? Yeah, we are. So the position of let's see here. So we're gonna have x1, that is this the first kangaroo, then we're gonna have x2, the second kangaroo. We can definitely say we're gonna be working on a vector or a x-axis. This is trying to be a pointer here, but I don't know what I did there, guys. Sorry about that. Anyways, just bear with me here. Let me just try to get a straight line for God's sakes. Here we go. So we just have to determine if at some point in time they will meet, right? So conditions are kind of explicit a little bit in a sense of they they both start. We can assume, right, that they both start at different positions all the time. Because if they start at the same position, and I'm just gonna go ahead and copy this thing right here, it could be a good way to go over the edge cases, or not edge cases, but different cases we can cover. So let me go ahead and group these. I'm just gonna use these things as elements for right now, so I can move them like this. All right. So the idea here is that I'm gonna check two cases. So the one where they start at the same position seems more interesting right now. Let's go ahead and check that one. If they start at the same position, can we go ahead and return yes because they're already meeting? No, it's gotta. They're jumping, so it's after the same amount of time. So jumps are gonna be involved. So if they start at the same position, the jumps or the velocity has to be basically the same. Because, and I'm just gonna go ahead and represent that like this. Oh, what did I do? Oops, sorry about that, guys. I'm just gonna go ahead and represent this like that, right? Velocity and velocity 1. So they're at this point in time, and they're at the same position. The only way they can always meet or somehow meet in the future is if their velocities are equal. Because if they start at the same position, and let's say this guy is faster, and I'm just going to go ahead and say that that velocity is equal to 3, and this velocity is going to be equal to, I don't know, 1. They're at the same position, so this guy is always going to be ahead, because his next jump is going to be 1, 2, and 3, right? And this guy's next jump is going to only be 1 right here. So, oops, that's the problem with drawing here. But anyways, his jumps right here. So, that's something to think about. If velocities are equal, then the positions must be equal. The starting position must be equal for them to ever meet at the same point in time. Because if not, then this is going to happen right here. Where, oops, I don't know what's going on. Here we go. This is going to happen where they would never meet because one is going to have a greater velocity. So in the other case we have here, we can say, and I could be going totally the wrong way, so it's fine. It's part of the learning process, as we mentioned before. So in the other case, we're going to assume that this guy is going to have a larger distance, right? But this guy is going to have a greater velocity, because that is the possible only way that they could meet. So let's just go ahead and do this. Starting point of x1 is going to be 0. Starting point of this guy is going to be 2, 3, and 4, just for sake of simplicity right now. But this velocity, the velocity of this guy is going to be equal, let's say 1, 2, and 3, and this one. So this velocity is going to be equal to 3. This guy's velocity is going to be equal to 1. And after the first jump, they'll meet at position 3. Right? 1, 2, and so 1, 2, and 3 right here. And this guy will meet with the next guy the next kangaroo right here, because again, one's kangaroo distance was greater than the other one, but the other kangaroo's velocity was greater, or jump range coverage, right? There's definitely a formula for this, because we don't have to return though. We don't have to return where they meet. It would be different if we have to return the point in time where they meet. But definitely we need to find differences here. So let's see. If one kangaroo's, let's try to use that one of the examples from here. I'm just gonna go ahead and try to copy one of these examples and try to check it out over here. Can I do that? Yeah, here we go. Perfect. All right, so let's say one kangaroo's okay. All right, so position 0. I'm just gonna go ahead and do another one right here real quick. It's not gonna be perfect, but we know what this represents. So let's say that, you know, kangaroo 1 is gonna be here, and 2, 3, and 4, and 5, and 6. That's kangaroo 1 with velocity of 3. Kangaroo 2 is going to be 1, 2, 3, and 4. Kangaroo 2 is going to be all the way up here. That's a cheater, anyways. And velocity of this kangaroo is going to be equal to velocity of 1 equal to 3. So let's just go ahead to make this simple, because it looks like a thing. I'm just going to go ahead and put the velocity right up here. Is that okay? I'm not using the best. Yeah, I'm just going to say this kangaroo has a velocity of 3 and this kangaroo has a velocity of 2. Right? x1, b1, x2, b2, right? So let me put some numbers here so we don't go crazy doing saying what this guy's doing. Anyways, we know the answer for this is yes already, but what I'm trying to find out right now is the difference, right? So if I say that 0, if I say that the distance of the second kangaroo is always going to be ahead, right? We already know what happens when it's equal, right? If the velocity is equal, the positions have to be equal for them to meet. If the velocities are different, if the velocities are equal and the positions are different, then they would never meet, because at the same velocity they can't catch up with whoever is ahead, right? But for the sake of the example, we're going to say that the second kangaroo is going to be ahead. So the difference of that would be 0, 3, so it would be 4 because he's ahead, right? That's the second kangaroo right here, right here. And the first kangaroo is, this case won't make much sense, but the first kangaroo is at position 0. That's the difference between their distance, right? And one kangaroo is going to be faster than the other, so it can catch up. So we'll assume that the kangaroo 1 is going to be the faster one. We'll say this kangaroo minus so this guy, right? the velocity 3 and 2 minus 2. So 4 minus 0 is 4. Now, I think I'm doing something wrong here. I don't know. I'm just trying to find the difference. 3, it's 1. So, that's the difference in distance. And this is the difference in velocities. I know there's a formula somewhere to find the distance. I'm trying to stay out of Google right now, but it will be for me to find that. I will go on a whole tangent right now trying to find the distance, the formula. I go crazy. But anyways, so I have the difference of these two. So if I say that these two kangaroos, so in the first jump, this kangaroo at velocity of 3 will go 1, 2, and 3. And this kangaroo in the first jump will go to 6. Let's say this is his first jump. Let's say this is his first jump. I probably should be using colors to kind of find that out. Remember, we're moving into the infinity here. In the second jump, though, the second kangaroo, and I'm gonna go I'm gonna try to make these easier. Maybe it's not gonna be easier, but let's see. I'm trying to make colors so I don't make a mess earlier or later. Anyways, that's the first kangaroo jump. That's the second kangaroo first jump. They're both the first jump of both of them. And the second jump of the first kangaroo is going to be, maybe I go this way, 1, 2, and 3. And this kangaroo, so I'm gonna do 6, 7, 8. They'll probably meet up here. Let's just put 9 there. And the second kangaroo in his second jump is going to be, so let's do 1 and 2. And this kangaroo, let's say this is his second jump. This kangaroo is his second jump. So far they haven't met, because we know they're going to meet in the next jump, right? Which is going to be at 12. I should have probably used one of those lines. Let me see if I can delete these without deleting. Oh, just that. There we go. So let's go ahead and say, oh, we have a green line, but anyways, probably can change it here. Nope. All right, just bear with me, guys. I still learning this thing. I would love to do this on a paper or something, but then I can't show it here, and it's cooler when you show it and everyone kind of loops and understands. And so we got 10, 11, and 12, right? So what happens on the third jump? On the third jump, it's that we know where they meet. Just so I forgot some. I'm trying to make this make sense. And the third jump, then it's gonna be 1, 2, and 3. So okay. This is the second. Okay, I was doing some. So this kangaroo is gonna jump 1 and 2, and this other guy is going to jump 1, 2, and 3, and then 1, 2, and 3. I'm just gonna go ahead and do it like this instead of doing it 1 by 1, 3, and 4. The fourth jump. This is basically the same example. I'm just trying to loop around 1 and 2. Okay, perfect. So third jump, fourth jump. They both meet at the fourth jump here, right? So 12 So 12, it is 12, it's a multiple of 4, right? And that's the whole thing. That's what I'm trying to get there. I guess I just could have gone back to the thing, to the little image there. But anyways, we're learning, right? We figure out ourselves. But yeah, 12 is a multiple of 4. So we don't have to print this number, which is kind of like what is kind of confusing to me, because it will be cooler if we would just have to say, hey, they're going to meet at this point in time. But they're not meeting there yet, right? But anyways, going back here, this is looking a little messy. I'm not trying to mess you guys up. But the difference in these two has to be a multiple of the place they meet, the position they meet after their displacement, right? So but we don't have to return that number, but that's how we know they met, or they meet at some point in the future, because we can basically say that this is time. All this is time, and they're gonna meet at this point in time right here. But how I don't need 12, but how do I figure out that that's where they meet, right? And that's where I think the formula comes in, because this is basically what I'm saying here is basically saying x2, assuming that this guy is gonna always be ahead, right, of this guy, and this guy here is going to be always faster than this guy right here, and we're just trying to get the difference of that, right? And those numbers, as we saw here, have to be a multiple. I'm trying to figure out, I don't need the difference of them, because that would be 3, and that doesn't make sense, you know. 4 minus 1, 3, that doesn't make sense here. Wait, maybe it does. Wait, maybe it does. No, because it's got to be a multiple of the place they meet. I guess I could use division here, but the problem, this would just be equal to 4. 4 by 1 equals to 4. So, but the problem with this, the problem I see here, doing it like this, is that I'm using, I have 0 here. But if at some point I get thrown, like this distance could be, I don't know. Let's try to do it. Let's try to do the example real quick. This distance here could be 1 or 2. Let's say 1. Now this number becomes, I'm trying to get there. Here we go. Sometimes I have problems with my tools here, guys. But anyways, this number becomes 3. And 3 divided by 1, it's 1.5. So that gives me a floating point number, and that's a problem, because I don't see okay, so that's a problem because they have to meet on a whole number, right? So they having to meet in a whole number tells me that Let me just go back. Okay, so let's go ahead and use something cooler. We can use a Python feature here. We can go ahead and use a mod operator here. And you know what? That might be perfect because for mod 1, it's going to be equal to 0. We don't have any reminders. We don't have any reminders. But what that's saying is that this difference, the difference of these values, is going to be a multiple of the point in time where they meet. Right? I think so. I think I'm missing something here. Well, I'm assuming, what I think is, I'm assuming by condition that one kangaroo is always going to be ahead and one is going to be faster, and that's gotta be the case because we already said if the velocities of these kangaroos are equal, then the distance must be equal too, right? Distance, which is x1 equals x2. So that's a case, that's going to be an edge case for us because it's got to be if the velocities are equal, the distance must be equal, because if the velocities are equal and one kangaroo is ahead of the other, we already know that. So the other case, it's the opposite case, but it covers the same one. Sorry, I just had to think about it. But if the positions are the same, the starting positions are the same, but the velocities are different, one would be faster than the other, that one would never catch up with the other one. So this basically covers both of those edge cases, right? So our assumption could be right. This is a good example because it fits perfectly, right? Where after four steps, they land on position 12, which is a multiple of 4. And I think to get the multiple, we can use mod operator here, which is nice. And we avoid, like, if this value is not 0, then it means it's not a multiple, so they're not meeting at any time, right? And I can go back to the other example. That's kind of messy. Again, but I think I did it here. Yeah. So when I put 2 here, did I change that? No, I didn't change that. Anyways, yeah, this example right here, I just changed one thing. Sorry about that, guys. You guys are going crazy. Like, what is this dude doing there? Nope. Oh, nope. 7. I'm gonna need a class on next college or whatever. But yeah, this is how that works, right? The other one with the 1 there was, this number was equal 3, and then I was gonna get a 1.5 here. No, that was with the division. Because I do 3 mod 1. Can I use the mod operator here? 3 mod 1 equals 0. Yeah. 4 minus 1 equals 3 equals 0. So that case would work too. I don't know. I just think I'm missing something here. I really think I'm missing something, but I can always give it a go because I kind of want to do another example, but also I don't want to make the video too long. The other video is just being a little longer, obviously, because I'm in the learning process and trying to show as much as resources and stuff. But let's go ahead and give it a little try first. I'm trying to see if I can do it in Jupyter Notebooks. But let's just go ahead and give it a try first here. And let's say we said we had an edge case where if these things are equal, the distance must be equal. So let's start with that. We're gonna say if the velocities are equal, the velocity of 1 is equal to the velocity of 2, then we're gonna go ahead and return no, unless return no. If velocities are equal, let's do it like this. If velocities are equal, return yes. Yaks. Return yes if the distance or the starting points are also equal. Else, return no. And that way we cover our both cases we mentioned earlier, where one kangaroo has to be faster and the other one has to be ahead in time. Because if not, then they would never meet. Okay, I got a problem here. I see it. Else no. That return statement, it's in play. So we can say if, assuming that the second kangaroo is always going to be faster, so if the difference between their distance, it's a multiplier of, and we're using the mod operator here. We can probably use the floor now, because floor is just going to give us the closest integer. We're trying to get a multiplier, so no. I don't know why I think I'm missing something here, but assuming that the second kangaroo is going to be always ahead of the first one, and the first one, for it to catch up, has to be faster than the second one, right? And that's all we're doing here. If these condition equals 0, so if it's a multiple, then we're going to return yes. If it's, and then if it's not a multiple, then we return no, right? Get that right. If the difference between these two is a multiple, okay, if the difference between the starting position of the first kangaroo and the second kangaroo, it's a multiple of the difference of their speed, then at some point they'll meet, and this just represent that it is a multiple. I don't know. We'll see. I just want to see what the test case. Ooh, okay. I see I'm missing one. It said yes. The expected is no. 0, 2, and 5, 3. Oh, that's the second one right here, right? Yeah. Interesting. What am I missing? Turn yes. If the velocity of the first kangaroo equal the second one, return yes. These velocities are not equal. Okay, so that's not the case. If x1 equal, return yes. If x1, else no. So if this is, I think I'm good there. If the difference between these two equals 0, return yes. Then return no. I would love to see another case. I got this example, right? Because that's the one I used for the second one. So I'm saying yes. I'm saying that they meet, even though this guy is way ahead and way faster. So way ahead and way faster. If the difference, maybe I say multiple equals, I'm just gonna try to put it here instead of raw dogging it like that and say that's the formula for that. If the result of that is equal to 0, could it be because it's could it be because this number might not be an integer, or might not be equal to 0? Can I doing this? I'm trying to find if I thought, oh, not what I was looking for. I thought it was a function when you check if it's integer as integer. It says integer rate, integer. No. Let me go ahead and run this thing again. Oops. I'm gonna put the camera over here. Let me go ahead and run it multiple. What am I doing here? Jesus. You guys see me doing that and don't say anything? Come on, man. Yeah, I'm missing something here. I knew I was missing something. What am I missing here? Multiple. If you're multiple, then otherwise return no. This number has to be 0 because they have to meet a whole number. I cannot have the multiple has to equally divide the difference between maybe it's not the mod operator. Maybe I'm looking for the wrong thing. Man, I want to Google something so bad, but I feel like I'm gonna be disappointing myself. Again, math is not my #1 subject. I know I'm probably missing something here. If multiple equals 0, what am I missing? Just gonna say formula displacement. No, it's not formula of displacement. What am I missing? I can figure it out. Distance. Okay, I know what I'm gonna do. I'm gonna go to the visualizer. I was trying to solve these as fast as possible. I thought I was gonna do it under like 45 minutes or whatever, but honestly this one was a curveball. This was a curveball I wasn't expecting to do, like, and it's not hard, like hard math or anything. It's just like I know I'm missing something. Am I returning on the right place? I'm just gonna go ahead and call these right here. I just want to debug a little bit, and this helps me understand how the code is working in the background. Again, the whole purpose of these is to actually learn. So I'm not trying to find a solution. I'm just trying to, I'm trying to find a solution. What I'm saying is, like, I'm not asking anyone or Googling any solution or anything. I just want to see how my code's working so I can understand what I'm doing wrong and then fix it. And that's how I learn. Once you know how your code works, and you learn. This is the case where it's failing. So I want to see what's going on. We call x2. Okay, if velocities are equal, which they're not, then return yes, unless they're, so that case we know we pass. We get the multiple, which is equal to 0, because why is that equal to 0? Am I doing something wrong? I'm assuming here that this one multiple, so it shouldn't be, okay. So x2 in this case is going to be 5. So right here, so you guys can see it, and I can see it too. So 5, which is x2 minus x1, which is 2, 5 minus 2, right? And then it's equal to 3. What happens if I do mod? So 3 mod 2 minus 3. That number is equals 2. So okay, order of operation. Thank you. 5 minus 2, 3 mod 2 minus 3, 1 minus 1. How is 3 minus 1 Huh, I can figure out what's going on. Can't figure out what's going on there. I thought that finding the multiple would help me. And yeah, obviously it's coming as a 0. So would it work? And yeah, return yes, because it's multiple is coming as a 0. I wonder if I know it's not my edge case. But I can rule something out if since I'm assuming that one kangaroo is always going to be faster than the other, I could say if the velocity of the first kangaroo is less than the first kangaroo would turn. No. And this might be completely wrong. I just want to see if I can crack another edge case. I just run the test. The test passes because it goes through the other side. Oh wow, look at that. Look at that. We're almost right, guys. We're almost right. Just one edge case. Yeah, so what I was thinking is, because I saw it here, I'm bypassing a lot of conditions with this, but I'm also assuming down here that the velocity of one kangaroo is always going to be the same, different. But if the velocity of the first kangaroo is less than the second kangaroo, you can immediately just return no, because the second kangaroo would never catch up. Right? That's what I think. I don't know. Let's unlock. I'm gonna pay the 5 hackos or whatever to see the edge case, because I want to see. I want to see this. I want to see this test case. Wow, these problem really like 53 minutes on it. I mean, I said math was not my fort, so give me some grace here. Let's go ahead and say the same condition. If B1 is less than B2, then return no, because they would not be able to catch up. But visualize execution. 0 division error, integer modulo by 0. Oh, I didn't think about that. I didn't think about that. Zero division error. Okay. So now I know we solved the problem with this condition. Now I have to see kangaroo that passes here, where it's going to say x2, which is 70 minus 43. So 70 minus 43, you got 27 mod what is velocity 1? 2 minus 2. We're dividing by 0 there. We're saying mod 0 there, and that's not going to do anything. So I see what I did. Like, I change. If velocities are different, I could say, and I would definitely bypass that, or velocities are equal, return no, because we're always going to have an integer 0 division, right? Since we are, okay, this might be it. Since we are getting the difference of these two, if these velocities are equal, then our modulo operator, it's always going to be divided by 0. So we're going to get a 0 division error. So that should solve the problem. Go ahead and send it. Let's go. Let's go. Let's go. Give me the confetti. Let's go. Yeah. Woo, that felt good. I did that under an hour. Which is pretty good. I don't like you, HackerRank. This is not my favorite problem. They don't have a button for you boat it down. But anyways, this was not my favorite problem. But I hope you had enjoyed something, or I hope you enjoy the content, and I'll see you in the next video. Let's go.